All right, now that we have covered the geology basics, we're heading into a tour of the water cycle for most of the rest of the semester. And I want to start with this figure of the water cycle because it has most of the parts in it, maybe a little extra. We are going to start today with stream flow. And stream flow is going to be what carries water from the continents to our ocean basins. We're going to talk about how water gets into streams and some of the environmental issues related to streams. We're going to talk about the shape of streams, stream channels, stream gradients, erosion, deposition, everything we can to talk about streams. They are just one part, though, of the bigger water cycle. So water evaporates from our ocean basins, condenses in the atmosphere, we have clouds, there's precipitation here in these highlands. Volcanoes release water under pressure, really hot water as steam. There's ice and snow that accumulates in our mountain ranges. If it doesn't melt season to season, year to year, it becomes a glacier. So we will talk about glaciers too. That water, the precipitation and water coming off of glaciers can infiltrate to become groundwater. Groundwater flows from high to low. It recharges streams. It makes it to our ocean basins. Along the way, there's also evapotranspiration, where there's evaporation from the continents and transpiration from the plants. Okay, so we're going to go over all the different parts of the water cycle today, starting with streams. And we are also going to talk about flooding. So streams and flooding. Why do we care about learning about streams? We want to learn about streams because they're crucial for humans. We use stream water as drinking water, and on campus at Appalachian State University, we use stream water that is collected in a reservoir and gravity fed to campus. It's one of the only universities in the United States with its very own water supply. We also use streams for transportation, waste disposal. We can put, if the regulations are right and the water quality standards are kept high enough, we can remove waste in our stream system. We also recreate in streams. I recreate pretty regularly in streams, either kayaking or I snorkel in streams, and I whitewater raft in streams, and I stand-up paddleboard in streams. We use streams a lot in our family. For commerce, so moving goods to and from places, the Mississippi River is a big conduit for commerce in the United States. We also mine our streams and pull water off for irrigation. We'll talk about the West and the Colorado River and how much water is taken off for irrigation later in this section on streams. We also use streams for hydroelectricity. We can dam a stream, give us a hydraulic head that's high enough, let water drop down, kind of like a fake or man-made waterfall, and generate electricity that way. So we'll also touch on hydroelectricity. All right, we got to think about streams in a couple different ways. They're powerful agents of change. So one of the main carvers of our landscape are streams. So we're sculpting the landscape. The streams of the continents also are moving sediment. So sediment is eroded, transported, and deposited by streams. We talk about all three of those things. It transports the mass from our continents to our ocean basins. So, for example, the Appalachian Mountains used to be as big as the Himalayan mountains, and now all that mass makes our really broad continental shelf out in the Atlantic Ocean. Earth is the only planet right now with flowing water. On the left there, though, is a what looks like an alluvial fan or a delta on Mars. So there has been flowing water on Mars. On the right is a similar structure, a beautiful river delta in the northern part of Russia. Okay, getting water into the streams, the recharge of streams. Recharging that water supply, because water is moving downstream, so the water that was in the stream is now gone. So how do you maintain that water supply? It's done in part by direct precipitation or snowmelt. So either rain is going to fall directly into the stream or snow is going to melt and that water will flow into the stream. There's also surface runoff. So water precipitation is going to hit the ground and run along the ground surface and then can land into the stream. Next is water flowing through the soil. So this would be water that infiltrates, hits the ground, and then goes into the subsurface and then flows downslope into the stream. Okay, so we have these different mechanisms to recharge a stream. They've combined kind of 3 and 4, the groundwater flow through the soil and the infiltration to hit the water table and recharge the groundwater that then recharges the stream. There's the groundwater recharging the stream. Forming a stream. The stream begins as sheet wash. This is literally like a sheet of water flowing down a parking lot, like in the image here at the top. It's not channelized, it's just flowing along the surface. That sheet flow then is going to eventually coalesce into little lobes that form into a little channel. Those channels then are going to form little places called rills. They're little tiny rill channel. The rills are going to come together to form a trunk stream over time. So little tributaries, tiny rills, sheet wash becomes tiny little rills, becomes tributaries, becomes a trunk stream. Once those rills come together and form little tributaries and trunk streams, they have an erosive power that allows them to downcut and to actually form a channel. So over time, they're going to form a channel where the stream then flows. Streams then are going to have what's called headward erosion. In this image, the background back here with this big flat area is the headwaters of these valleys. And so if we pick this one here in the middle, this point right here, I'm going to circle it, this point right here is moving away from us, right? And so it's eroding towards the headlands, this flat area. So each of these little valleys has headward erosion up into like this plateau. That would be kind of what it looks like around the Blue Ridge Mountains. In this image on the right, this is a desert area, and the same thing is happening in these canyons, like this point right here, right here, right here. That is headward erosion. So it's eroding upstream. Over time, these tributaries come together and form a larger trunk stream. So in this image, these dendritic or tree-like patterns all are draining the hilly areas and coming together, and I'll outline. This is the trunk stream down the middle of the image. Those dendritic tree-like patterns are draining down into the main trunk stream. And the pattern, like the dendritic pattern and the meandering of this stream, is going to be dictated by the underlying geology.